Okay, so on this one now, what are we going to do? They're saying find the degree, leading coefficients, maximum number of real zeros of the polynomial. Okay, so first off, what is all this? This is kind of the lingo. Degree means highest power. What's the highest power? 5. Leading coefficient. That means the number in front of the highest power term. It means what's in front. Well, it's this guy. What's in front? Nothing but a 1. There's nothing there, so it's really 1. Is that confusing? Is that making sense there? So when there's no number, you know that when there's no number in front, we say there's an invisible 1. So it's 1. What do you mean there's an invisible? Oh, I'm sorry, it's -1. I better look more carefully. It's -1. I can't forget about that. And that negative sign is part of the deal too. So it's -1. Why is there a 1? Well, because it's like it's already there. Why? Because what is 1 times x to the 5th? It's still x to the 5th. It doesn't change anything. So there's really a 1 there. It's just 1x to the 5th. In this case, -1, because there's also a negative sign. So it's -1 times x to the 5th is -x to the 5th. So there we go. That's what we got going on. And then what's the maximum number of real zeros? Now what are they talking about? Maximum number of real zeros. Well, think with me for a second about a graph, and I bet we can come up with it. If I was to give you y equals x squared, you know what that looks like, right? That's a U shape like this, huh? Okay. And what is well, first off, what's a 0? A 0 is where the graph has a height, which is a y value of 0. That's why we call it a 0. This graph has no zeros. This graph never hits it. But what if we redid it down here? Let me try it again. What if we moved it down like this? And now that one's got 2 zeros, right? Because those 2 points both have a y value of 0, a height of 0. So what's the maximum number? Well, let's think. X squared, the maximum number of zeros is 2. So probably the power tells you the maximum number of zeros, the most it could have. I mean, it could have no zeros, as we saw, but the maximum, the most it could have, is whatever its power is. Do you see how I came up with that? I just looked at the pattern. Math is just patterns. So that means the max number equals the highest power. The max number of zeros, I should say. The maximum number of zeros equals the highest power. Do you see how I just came up with that? I just looked at an example. I just thought, what do I know? I know x squared, it's a U shape. What's the most it can do? What's the most it can have a height of 0 and hit the x-axis? Twice. Oh, so the power must tell you the maximum number. So what's the power on ours? 5. So this must be 5, maximum number of zeros. Let's go see that on the actual question. Let me go there. There it is, number 3. So this one, for example, notice how the 7's in the front. Here, let me do a new one. What's not? There we go. The 5's in there. So what's the degree? It should be 5. What's the leading coefficient? 3. It's the coefficient in front of the most powerful term. What's the maximum number? It should be 5. Yep. So there it is. See how that works? It's the highest power is the maximum number of real zeros. That's exactly how that works.
And then, I'm sorry, you said lecture 5.2 is due tomorrow, correct?
Correct.
Okay, because On ours, I think it says it's due Monday.